So Gideon, tell us a little bit about the work that you're doing right now in automotive.
In automotive, our focus is very much on sensor to ECU connectivity. Our core technology is high speed, high bandwidth, resilient connectivity. Our core competences is a digital PHY, which is very scalable and resilient to noise and delivering ability to communicate raw data and raw video over long distance, which is very important for the automotive industry. Our technology was also recognized as the base for the new MIPI A-PHY standard, which is the standard for sensor to ECU connectivity moving forward.
First, what are the main challenges when it comes to achieving mass production of software-defined vehicles? And then second to that, how is Valens helping to solve those challenges?
All those challenges, right, in the software world eventually need a very strong hardware infrastructure to be able to be established on top. So the software-defined vehicle must have a future-proof hardware as a foundation, right? And this hardware needs to be scalable from a bandwidth perspective. This hardware needs to be resilient to noise, to electromagnetic interference, and it needs to be also power efficient. And let me say a few words about this, right? Scalability. The whole idea of the software-defined vehicle is that you can upgrade it and improve the performance as you go. So you must have an architecture, a hardware architecture and implementation, which is scalable, and you don't need to redesign it from scratch with every generation. And then resilience to noise. If your car is driving near a cellular antenna and a glitch is suddenly happening on the link between the sensor to the ECU, the ability of the autonomous or the ADAS system to function is at very high risk, and the software-defined vehicle will be much more sensitive because of all the applications that are built around it. So you must have very high resilience to noise. And then power and low-cost infrastructure. With the electrification of cars, power is a top priority. You can have an excellent software-defined vehicle, but if the power consumption of the hardware is increasing because of the complexity, then the range that you can drive will be reduced. And those dimensions of the hardware, scalability, noise immunity, and power efficiency are the foundation of what I call the future-proof hardware, which is required for the software-defined vehicle. And solving this is challenging. You've asked, so what is Valens contributing? As I said, we are focusing on high bandwidth, high speed connectivity. We are at the hardware layer of the software-defined vehicle. We are enabling the resilient connectivity between the sensor and the ECU. Our technology is enabling the scalability, the power efficiency, and the resilience to noise, which is essential for the software-defined vehicle.
Gideon, you'll be joining us in Brussels in September. So tell us, give us a sneak peek of what you will be showcasing at your booth and what we can expect to see.
We will also be showing some innovative architecture you can build around the MIPI A-PHY, right? So I've mentioned the diversity of use cases that we are working on. So let me maybe highlight two. One is a surround view system where it's a very innovative from the infrastructure we are working on. We are demonstrating a very low-cost surround view based on low-cost wiring harness, unshielded twisted pair. We are the only one who can do that. So we have an exciting demo of this surround view over unshielded twisted pair. Or on the other end, on the high end, the new radar architecture, which is evolving, that is called satellite radar, where you separate the radar from the compute. You need a high bandwidth resilient link to bring several radar data into a central compute. We show a demo of this as well. I think this is very exciting for ADAS and autonomous driving, and I'm sure customers who will come to see will be very much excited from the new things we are showing.